Hi everyone, welcome to ArcMap complete tutorial. And actually, I had this video on online for more than a year, and it had over 500,000 views. But YouTube deleted this video as I showed some ways of installing ArcGIS, which went against their guideline. That's why. So now I have just made some modification and going to upload it again. And soon I am going to make a new video on ArcGIS Pro, and hopefully you will enjoy that because I'll add some new things, especially maybe Raster. Yeah. So without further ado, let's get into the video.
After covering or watching at least 1 hour, you will be able to make a base map like this or that. Okay, so I would say, yeah, that will act like a fuel to keep you watching the tutorial at least 1 hour. So without further ado, let's get into the video. So at first we will introduce you this interface. You can see this is our layers. Whatever we will load in this ArcGIS, you will see that they pop up here. Now by anyhow, if it got deleted, then you can again go to this Windows and click on this table of contents. It will be back. Okay, fine. Now you might have one thing right in this corner, but I don't have. But if somehow it got deleted in your case, then again go to view and this layout view. Yep, now you can see that in this corner that appears. Okay, now these are some tools. You can see, you can also drag it, place it anywhere you want, but make sure that when your cursor appear changes, that's the moment when you can do that. Okay, you can also add new layers. Let's say I want to add this advanced editing toolbar. You can see this is not here, and to delete it, you just uncheck that. Okay, uncheck it, draw. Fine. And now let's see how to load data. There's two ways to load data in ArcGIS. One is this one, this add data. Just click here. It will show you don't have this data at the beginning. So to add, you need to at first connect your folder with ArcGIS. And another way of adding data is using this catalog. Okay, this catalog, this is the easiest one, and I think if you are a heavy ArcGIS user, you would prefer to use this catalog always. Now how to connect folder? At first to connect folder, you can see connect folder, this plus button tab here, connect to folder. Just click here and navigate to the folder which one you would like to connect. If you don't connect a folder, then you can't import data from that folder. Okay, so let's say anyone you want to connect, just click here and okay, click OK. Okay, it will pop up here. Then you can load data by this from this catalog. You can add data by just, let's say this is my shapefile, just drag it here. You can see it's loaded, and from this add data section you can do that also. Just folder connection GIS, just navigate to the folder where you stored it, and yeah, this. So these are some ways how you can add your data. Okay, and you can also make new files, folders. Let's say in this location, right click here and go to new, then folder. It will create a new folder for us. You can also delete it. That's it. So that's all about a bit of, I would say, a brief introduction on this interface. Now we'll take a look add a bit of theoretical knowledge. Theoretical knowledge of GIS data types. There's two kind of GIS data in ArcGIS. One is vector data and another is raster data. Okay, so let's see them. Now, in the above section, you can see these are actually vector data. There's three kind of data storing ways in ArcGIS. One is using point, another is line, another is polygon. So we use vector data to store data in our GIS format actually. So you can use three way. So in vector data case, we represent data as point, line, or polygons. On the other hand, in the case of raster data, data are being stored as grids or cell size. You can see here, this is one just point, one single grid cell. Here, a line like a line of grids, or here like polygon of grids, multiple, huge. Okay, so in this case, in vector data could be discrete. There's multiple boundaries here and there. Okay? But in the raster dataset, it's not discrete, it's continuous. Okay, now in the case of vector data, there's two other type of data type. One is shapefile type, another is geodatabase. That's actually a data storing extension type. So, and people would prefer to use geodatabase, and we'll see that why we use or prefer geodatabase in the later part of this video. Now let's see all those things into action. In this tutorial, we're going to learn how to create a new customized shapefile of your own, and we'll just not confine ourselves within shapefile. We'll also see how to create personal geodatabase, and you might assume that everybody using shapefile, but it's not the case in professional life. In professional life, you will see that everybody using geodatabase. So we'll also see how to create geodatabase, and so let's see that. At first, we're going to see one template, and this is what we're going to create right now. Okay. So over here, you can see that we have what here some landmarks. This green colored triangles, and this is a school, and this red line is, let's say, it's a road or river, whatever. Now if you want to edit this shapefile, you can easily do that. Let's say how. Let's say you want to add more schools, and you can change the attributes level of them also. Here you can edit it, name code. Okay, you can also add more points and polygon also. So I would like to enlarge it. Yep, so you can enlarge it, you can do everything you want, and you can also change the attribute table. Okay, so let's go ahead and see how to create at first this shapefile, then we'll see how to create such geodatabase. Okay, so we're going to start with a fresh one. New blank map. Okay, now I got a blank map. Now to create a shapefile, you can create a shapefile in any folder you want. So let's say we would like to create that on this folder GIS tutorial. Right click here and go to new, then file. Oh no, we are going to use shapefile. Create shapefile. Okay. Oh no, not again. Now we are going to, let's name it shapefile shp, and it's going to be a polygon. Then a coordinate system. It's very important. So geographic coordinate system. Oh shit. Geographic word, then WGS 1994. Okay. So that's our coordinate system. Then okay.
And yeah, our shapefile is ready. Now you can draw a shape easily. But to draw a shape, let's say I am interested in a particular area, I would like to draw a shapefile of that area. So I'm just going to load one base map. And the reason I loaded this street base map is because it doesn't take long time to load. But if you do imagery satellite image, then it will take huge time to load. Okay, now I am interested in, let's say, this zone. Yep, here. So you can easily, or is it editor? Yep, start editing. Now I'm going to draw a polygon. So to draw a polygon, you can just right click here, create features. Now, by the way, if you don't have this editor toolbar, right click here and go to check this editor. Editor. Okay. Now here SHP, if you just click here, you can create a shapefile. But in your case, you might not be able to do that. You need to first click here, then click here in this polygon. I just made a template actually. So to create a template, you need to go here, organize template, then new template, and check it, then finish. Now I have two of them. Close, delete on. Okay. Let's say this is my shapefile, polygon. Then I want to create a river shapefile. So let's again go to the catalog, then this GIS tutorial folder, then new, again shapefile, and it's going to be a river shapefile. So river is line, so it's not polygon now, so it's polyline. Again you need to specify the geographic coordinate system. Okay, it was Word WGS 1994. But if you are going to create a geodatabase, then you don't have to write or specify that geographic coordinate system again and again. It's just a one time. Okay, now we have created our river line. So let's draw a river. We don't have that river template here. So river finish. Yep. Now we can digitize it. That I think you got the idea. So I'm just going to make on randomly. Okay. So when you are going to finish that, just double click. And we haven't created any new fields yet. So you can create new fields. Right click here, go to open attribute table, and before creating a new field, you need to stop this editing toolbar. Okay. Yes. So add field name. Let's say we are just interested in that a river name, a road name. So yeah, name. Short integer name is going to be a string text. So text. Okay. Fine. So now start editing. This is our river, so we just activated it and right click it. Now you can see that name, and you can edit the name. Let's say it's river what, PADM. What that? Oh my keyboard. Okay, PD. That's it. So now what, you can also change the color of this river, and let's say it's highway like red color. No, red not. Okay, let's change the color to this blue one. Okay, fine. So it's changed. Now let's say, oh, now one thing to notice here is that before you start your work, it would be a wise decision to check the coordinate system of your layer, that is this data frame. And you can see it's WGS 1994, fine, same as our Shapefiles coordinate system. Go to properties, and under this source tab you will see the coordinate system. Where is it? There. Geographic Coordinate System, GCS, WGS 1994. Okay, that's fine. Now let's create another shapefile, a point shapefile, so that we can assign some landmarks. Okay, new shapefile. It's point by default, fine. Unknown coordinate system, go to edit 1984. Okay, so this is a point. Now you can change the style. Okay, fine. Let's see, point or new shapefile. I can edit that also. So let's point landmark. Okay, so now go to template, landmark, finish. You can add landmarks where you want. Now just make it hollow. Okay, so now it's not just about making a map and adding some landmarks. Your task also is to store the data for this map for such landmarks. So now we are going to store data in this landmarks. For this landmark, now to store you need to create a new field, and you can create field from this attribute table from here, or you can also create new fields from this shapefile. So let's I'm going to do that new shapefile. Oh, it's not updated yet, but I'm gonna properties. Now you can see here fields. You can add new field. Now let's say what name of this field, landmark name, or type, typ type is going to be text. Yeah, let's say we want to add a code for each landmark type. It's going to be integer. Sorry, yeah, integer means numbers. Okay, apply. Now let's see if that is updated or not. Yeah, it's updated. Yes, you can see here. Landmark type, code. Fine. Now for each landmark, start editing. Click here. Now right click here. You will see those type code. Let's say this is a what? It's a mosque, and for that code is 15. Okay. Sorry, you can do that by just clicking here. See? Now if you click here, now the attribute table is open for this landmark. Now here you can add that, let's say it's a school, and for this code is 20. Similarly, you can activate another one and again edit. But let's say you need to add thousands, you are going to add thousands of landmarks. Then each time you need to do select that one and again again add those data. Now there's another way of doing such thing. and that would be a bit easier for you. Alright, let's see that. So to do that, go to editor, then options, then attributes, and check this display the attributes. Okay, for the following, let's, and this is our landmark field. Apply. Okay, now whenever you are going to add one additional landmark, one window will pop up. See, type, let's say it's a house, and then code is 15. Now double click on OK, it will go away. See, really efficient one, and I found that really helpful in my working project. So let's type it, anything you want. Fine. So that's how you can enhance your working efficiency. Now let's say I want to cut one polygon, not outside this polygon, inside this polygon. We can also do that outside. Let's say I'm going to add another polygon. You can do that, right click here, just click here, and yep, no, it's a bit, you can also go back, undo what have you done, just, yep, again you need to cut one. Yeah, now it's okay. Now if you are going to cut one polygon inside already built-in polygon, then you need to check that at first, active that, then go to this cut polygon tool, okay, and then choose this one, straight line. That's why I'm interested from here. Fine, you can see one new polygon is created. Now if you want to add some data to the attribute table of this polygon, then just right click and go to attribute, and these are just by default field. You can add new fields and store data. Okay, let's see one another thing. At first I'm just going to create another, yeah. So now if I want to, let's say I want to cut a polygon just along this river line. So to do that, right click on this cut polygon tool, then go to this tool and select this one, trace tool. Now after that, just click here, then it will automatically follow the river shapefile, and double click at the end point. See, one new polygon has been created. That's really easy one. So these are some ways of cutting new polygons, and there's another thing to mention is that this sticky mob tolerance, this one, right now it's 0. I don't know what is by default one, but if it's 0, then there's going to be some problem. So it can make some distortions in your map you don't know even. Okay, so how can it make some distortion? Let's say you can move that map now, but sometimes you don't want to move them, but somehow they can be moved. So go back, yeah, so you can move them anywhere you want. Yeah, so you can go back actually, yeah, fine. Okay, so now let's see one thing, that is merging two polygons. Let's say I want to merge these two polygons. So to merge them, what you need to do is just hold shift key and click another one, then both of them will be selected. If you are interested in selecting more polygons, then again hold shift key and select another one. Okay, Fine. Now go to this edit tool, then this march, and now you can see that you have two options, either this one or that one. Now if you do this one, then the left one will be merged with the right one, and all the data of the left one will be vanished, and only the data of the right polygon will exist. Right now we don't have any data, so we can't see any changes, but that's one major problem of merging. So before you merge, be careful. Okay. All right, let's see another editing tool actually, which may save your time significantly. So let's say okay, now to overcome this problem, what you need to do is go to options and sticky move tolerance, make it to 999 or 1000, apply. Okay, and now you can't drag that independently. Fine. Okay, now let's say another editing method, not editing method, it's just correction method. So let's say, for example, I am interested in drawing this river line. So just river, zoom a bit. Yeah. So you got the idea. Okay. I'm just, to save our time, just randomly drawing it. Okay. Now maybe you don't want that extended line outside your boundary shapefile. You can undo that and create again new one, but in a large data set it's not possible to undo that and draw again. Okay, so how can I do that? So to do that, you can double click on this shape, and now you can see all those vertex. So you can see there's a vertex, there's another vertex, so we can just delete this vertex. Okay, now you can see that extended line is gone, but our shapefile is not just from the boundary. So to do that, what you can do is again double click here, then just drag it to here. Now you can see it's just from the boundary. So that's how you can correct some errors. And if you don't have that option, you don't see that vertex in identification, then go to this editor again and snapping. You can see, check this snapping toolbar, and you can see that right here, snapping toolbar. Alright, so far we have seen so many things. Now let's see one thing called labeling. How to label, let's say, those landmarks. So go to point, properties, then under this label tab, at first check this label feature in this layer, otherwise you won't see any label. Then here you can select the attributes what you want to visualize. So let's say I just want to visualize type, name of those landmarks, and here it's color. You can change the color. Let's say I'm just green, bold, apply. Yep, you can see this was a house, it was a mosque, school. Okay, here there was no data, it didn't store any data for this landmark, that's why it's blank. Fine. Now let's say you also want to visualize or want to see the code for each landmarks. So, and you can't actually, at a time you can't show two of the fields. Here there is no option. You just apply, sorry, you can show just one field, but there's one option for you. using this expression. So at first you need to select this parser, Python, JavaScript or VBScript. I would prefer Python. Okay, by default there's one field. You can delete it. So let's say I want to I want to visualize type and also code. So just you need to write plus, that is in Python concatenation. So type plus code. You can verify that here just to see that is it working or not. Yep, mask 15. You can see it's working. Okay, apply. Yeah, now you can see house code 15, school 20. Here you can see 0 0. These are just by default values. Okay, now one thing isn't looking good is that there's no space in between code and house. And let's say I want to show this 15, this code in new line. Okay, so how can I do that? Again, go to expression, and after this plus, for a space you can just give a comma quotation, again a plus. Okay, now you will see verify. Yeah, there's a space. Okay, now if you want to put a new line, then just \n. That would, yep, fine, \n. Now you can see house 15. Okay, that's a little bit of about what labeling. Now let's see how can I calculate area of each of those polygons. If you go to the attribute table, you can see there's no field for area. Now I'm just going to create one new field. So at first stop the editing session, go add field, name, let's suggest area. Yeah, I don't want to use that a, name HH, so you can name it anything. So it's going to be integer, that is number. Okay, and just to calculate area, you just right click here and calculate geometry. But you can't calculate area because area disabled, because we are using WGS 1984. So to calculate area, you need a projection system. You need to project it. That is UTM zone you need. We could have done that at the very beginning of making Shapefile, when we specified or assigned our coordinate system to WGS 1994. That time we could have assigned it to UTM zone. Okay, so okay, now we need to change it. That, so to change it, just you can do Control F, search, or you can do it from Windows then search. Okay, you need to project it. Yeah, what's the problem? PROJCT, project. Okay, go to this project under data management tool, double click here, then import data setup feature. So our shapefile, then output data setup feature class, here location actually. So I happened to actually what I usually store it in this folder in another new file geodatabase. Just give it a name and you can save it anywhere you want. Let's project that, project, save, output coordinate system. That's the important one.
How can I know that which projection system is appropriate for me? So you can simply go to Google and let's say UTM, no, World UTM Zone Map. Okay, just get. It's not so. Now you can see that from my location it's 46 here. I'm here, Bangladesh. You can actually find out one more transparent one. I did found one. Yeah, that's it. Now you can see that here is my study area. This one, it's UTM 46, and you can find it for your own study area as well. Okay, so it's UTM 46. So go to here, projected coordinate system, then UTM. Okay, WGS 1984, and it's in northern hemisphere. It was 45 and 46. Where is it? Yeah, here. Okay, then what? Transformation, preserve. Oh, leave them just alone. Okay. Yep, our projection is done. Now project. It's actually now a new feature class. I'm just unclicking all of them. Just this one. Now if you go to the attribute table, you should see new, yeah, shape length and shape area automatically, and I think it's in meter square. Yeah, it's in meter square. You can add another field, add field, let's say in kilometer, in what, kilometer. So it's integer. Yep. Allow null values, yes. Okay, so right click on it, then go to field geometry, calculate geometry. Then here you can see units, square kilometer. Okay, yep, you can see now 44 kilometer. This one 44 kilometer, then it's 46, 39, 73. If you double click here, then that portion will be zoomed. You can see over here, yeah, and it's really one powerful tool when you are going to visualize a large data set. Okay, so not tool, a technique. So before we dive into geodatabase, let's see one another thing, that is just delete it. Now we have this nice template, this green color template, let's say that this blue color river. But if we just now delete them all, okay, and again we drop or load our data shape files, you can see all those templates or styles are gone. So to preserve them, or if you just want to start, every time you want to start from the point where you left, so to do that you need to create one mxd file. Okay, now let's do a bit of change like the previous one. Let's just keep it red. Shape, okay, fine, that's it. So we are now going to save it. So let's save it, go to file, then save as.
You can save wherever you want. I'm just going to save as like GIS DU2. Okay, save. Okay, now I just opened a new one. Then go to the folder where you have just stored this mxd file. I saved it here. It's what name was GIS Topo. Yep, tutorial. Yeah. Yes, now you can see that all the changes we made the last time are now here. And now if you do, let's say, edit, start editing. Okay, if you change anything here or edit anything here, that will automatically be stored or saved in this point shapefile, river shapefile, or this polygon shapefile. Let's try one. So I am just going to cut a new polygon. Yeah, and save edit, stop edit. Fine. And now if again I just drag that shapefile, you can see, just unselect them, that change is already saved in that shapefile also. So I think that's enough about shapefile editing. Alright, so far we have seen how to create a shapefile and how to digitize it. Then we have also seen some of the basics of this editing toolbar. Now it's time to move on to geodatabase, how to create a geodatabase. Okay, so as I said earlier, geodatabase is much more efficient and easiest way of GIS data storing, and it's more accurate way actually. And geodatabase allows us to apply topological rules, but on the other hand, shapefiles doesn't allow us that. So now let's see how to create a geodatabase. Now we're now going to create a new one, blank map. Okay, now again in a folder we can do this in the same folder, GIS tutorial. Go to new, file, geodatabase. Okay, yep, so we're going to file a geodatabase. What's happening here? Yeah, so file geodatabase, you can rename it. Let's say I want to, don't touch that GDB extension. This is the file extension .gdb. okay, now let's say what, Geodatabase, GOD. okay, now right click here and again go to new and create a feature dataset. This feature dataset is actually to refer to each feature class a same geographic coordinate system or coordinate system. Okay, feature dataset. Now name the feature dataset. Let's say I am going to name it UTM46 because my UTM zone is UTM46. Next, now it's UTM5. UTM46. It's a it's a projection system, and if I do that, then you don't have to reproject your feature for generating area of that polygon. So next, leave that alone. Next, okay, next, finish. So we have created a, I'm just going to delete all those things. Yeah, I don't need them anymore. Yes, fine. So it's UTM46. Now in this feature dataset, now we are going to create new feature classes. What are actually feature classes? Feature classes are what I have seen earlier, that road dataset, then what, a polygon. These are all feature classes. So feature class sets up, we need at first we need a shapefile. So let's say it's a SHP file, SHP or shape. Okay. Alias doesn't matter. Polygon. It's going to be a polygon because it's a polygon file. Default. Okay. Next. Now this is attributes table. We can add some attributes in that polygon file feature class. You can add from attribute table also, but it's good to add from here. Let's say a name. I don't use that A because of my keyboard problem. Name is going to be text. Yeah, let's say one unique code, so it's going to be integer. Fine. Allow null values. Yes. Default value, you can also assign one default value. Let's say for code our default value is 0. Finish. Yep. So this shapefile is created. Let's say I wanna add another feature class, and that is going to be a road, ROAD. So it's like a rod, but I don't use A. Polygon, it's going to be a line feature. Next. Now you can see that you don't have to specify again and again that coordinate system, but in the shapefile, in the case of shapefile, we have to do that, but here we don't have to do that. So let's say again the road name or type, but no, right now let's say name. Yeah, name going to be text, then diameter, and it's going to be integer. Next. Yeah, so road shape. Fine. Now let's say I'm just not interested in one road. I'm interested in multiple road type. It could be local road, village, major highway, etc. So in the case of shapefile, you need to create another shapefile. Let's say for one is for major highway, another is for village road. But in the case of geodatabase, you can create subtype. So if I just write here on this property and go to what subtype, here subtype, you can create new subtype, and for subtype you need a field, and that should be a integer. So we are going to create another field for this subtype. So let's say it's type of road, but it's gotta be integer. Okay, integer. Now apply. Again go to subtypes. Now you can see we got that. Oh no. Cross. Okay, again go to properties and again subtype. Yep, we can see that type right now. So type, it's a new subtype, code 1. So description, that is the name of this subtype. Let's say I'm interested in this one. Oh, what I did. Major highway. Highway. Then number 2 is village road. Then number 3, 4, etc. you can add. I'm just interested in 2. Apply. Okay. Now just delete this road, remove, and again load that. You can see we have 2 new feature symbol, 2 road symbol, highway and village road. Okay, Now you can also create new feature class. That's going to be a landmark, LAND, landmark. Okay, it's going to be point feature. Next, and that's a type. That's a text, yeah, and code. That's going to be a integer. Finish. Fine, let's now add a base map. However we are interested in, we are going to just find that. OpenStreet. Okay, so this is now in UTM zone actually. That's why this shape, UTM 46. Okay, now let's say I'm interested in here. Okay, now to create new shapefiles roads, we go this create features, and already our templates is ready. Template is ready. Fine. Now let's say I am just at first shape. So say for example we're interested in this shape from this highway. So I do that. You need to do that carefully. I'm just randomly doing it. Okay, double click at the endpoint. Fine. Now make it hollow. You can also change the current symbol. Yeah, if you are interested in simple marker, fill symbol. No. Okay. Then highway. Let's say. So this is going to be a highway. Yep. Now village road or local road. Let's say this is a local road. Okay, at first draw highways. Fine. Now village road. Let's see this one. This is a highway. Fine. Now if you want to add data for this local village road, then you just need to click here, attributes. You can see name, whatever the name of this road. Let's say KZI road, ROAD. I am not going to write a diameter. Let's say 30 meter. Okay, then fine. And for this road, this one, just select it, then name XYZ something. Diameter, it's a bit high. Let's say 35. That's it. Again, you can store for this one. Now if you go to the type, let's go to table, open attribute table. Where is the type? Yeah, here you can see that the selected one, it's highway, we know that, and here you can see type highway automatically, and this one, it's local or village road. You can see this is village road automatically. Fine. And you can also change that here. It's like a domain, village road. Okay. Fine. Now you can change the symbology. Highways, let's say red color. Okay. And village road, let's say it's in railroad. Residential street, and color. Okay, now you can see that. No, that color is not good. Okay, now you can see highways versus local ways. So that's the beauty of what geodatabase. Now you can also create domain, but I'm not going to do that now. So to create domain, you can create just from this. Right click on this geodatabase, then properties, and you can create a domain here. You can also create specific domains. Let's search for road. Right click here, properties, and you can click from this domain section. Although we don't need any domain here. So fine, that's how we create geodatabase. Okay, now if we look at the attribute table, and see the area, you can see it automatically generated the area of this shape for us automatically due to just changing that coordinate system to UTM zone. Okay, and you can see that it's 16 square kilometer. It's given in meter square, so if you can just change it to kilometer square, you can do that. Add by just adding new field. Okay, now what? Let's add some points also. Yep, point landmark. So one landmark here. Then here, if you just want to store something, you can store here. Type, and let's say it's a house. Okay. Code 15. Then here, let's say it's a mosque or temple. Code 44. Okay, you can do those things. Fine. Now change that. For school, you can do SCHWL. School, you can search for schools. Schools, this is the school symbol. You can see symbol is changed. Now you can make subtype for landmarks, or just create another feature class. Let's say new feature class. We cannot create a feature. Okay, stop editing. Yes. Then again, what new feature class? Name library. Let's say library. It's going to be point. Next, and name text. Let's say and what now code. Integer. Finish. Now one library added. We can change that lib library this way. So if you now just start editing, want to add libraries, you can add them also. Okay, and by the way, if you're just interested in you want to know the coordinates of these points, you can do that. Just landmark, go to open attribute table. You need to create one new field actually. Then let's say here it's not code right click here, field calculator, no, not field calculator, calculate geometry. Yep. Now you can see x coordinate. So you can see here x coordinates. If you just give OK here, then you need to open another field, then again go to field, sorry, again go to calculate geometry, then y coordinate. So you can also have y coordinate in another separate column. Okay, so I'm not going to do that, just if you're interested in. Alright, let's now talk about how topological rules work and what is actually topology. Topological rules are actually some of the geometry related rules to find out the errors in your geodatabase. Is there any error? Let's say this road is a bit ahead from the boundary, so that's actually an error. So you need to find that error, but it's a pretty small data set, that's how you can find that out. But if it's really big one, and in real life you will have really big one, then you can't just visually see that. So you need to run that topology rule, then that will automatically say you that is, hey, there's an error, and you can inspect that. Okay, now so let's see how actually topological rules apply. So again go to catalog, then here in this UTM-46 or feature dataset, if you haven't created any feature dataset, you need to create one before applying topological rule. So right click here, new, you can see topology. Cannot create a topology. Okay, stop editing, save changes, yes, of course. Again, new, topology, next. Okay, next. Now select the featured classes that will participate in the topology. So let's say I wanna add what, road, landmark, and shape. Next, rank. Okay, that's fine. Next, add rule. That's the main point. Now features of feature class. This is our feature class, landmark. A rule must be covered by boundary. Okay, we want to all the points be in our boundary, so that this rule will apply on our dataset and will find out if there's any point beyond our boundary. Okay, we have added that. Add another rule. Now let's say not landmark, I want to shapefile. So must not overlap, or you can add many more. Must not overlap, must not have dangles, that is, it should have an ending point. Okay, add rule, must not also overlap, must not overlap. Okay, add rule, now it's for shape, rule must not overlap by default. Okay, fine. Next, finish. So let's see what it does. New topology has been created. Would you like to validate it? Yeah, of course. So just unselect this one. Now you can see one new layer has been created. Just drag it here. Do you want to what, add all the feature classes? Yeah, of course, yes. Okay, now you can see where is the issue actually. Now we got huge data set. Yeah, let's just delete all of them at first. Yeah, then again, yeah, yes, now it's okay, fine. So you can see these red points are telling us these are some errors. Actually this is not an error, because these are our school points. So what, there is no school point. So to inspect that, you need topological tool. What is that? Topology. Yeah, here, this one, topology. You can see it's inactive, so to activate it, start editing. Okay, now it's activated. So now you're going to inspect error. This window will pop up. You don't need that. Yeah, so let's see. Must be road must not have dangles. So for the search, I'll search now. I thought there's no error here, but it's showing us. So right click here and what? Zoom to, yeah. You can see we thought there's no error, but you can see here it's actually beyond the boundary. So to fix that, you can fix that by here trim. If you do mark as exception, then it will be just interpreted as it's not an error. Snap, show rules, select. Okay, now you're going to actually fix that. So double click here. You can see a vertex here. Just delete that vertex, and you can see now everything is fine. So let's see the next one. Zoom to. What's the problem here? I think it's fine, okay, isn't it? Yeah, it's fine. So mark this as exception. It's not a problem. Let's go to the next one. Zoom to the so now how can I fix that? Okay, just yeah. I think now it's okay, isn't it? No. Yep, now it's okay. So let's see the last one. Zoom to the layer. Again, you need to extend it a bit. Okay. So now just you're going to validate it. Validate topology in current extent. Yeah, it's validated now. So must not have dangles in that rule. We don't have now any error. Search now. There's one also. This one maybe. Zoom to this one. Okay, it's okay. Just mark as exception. Fine. So that's how you need to correct all of them. Must not overlap for shapefile. I think there's no, because we just have one single shape. There's no error. Must not overlap. Must be covered by boundary. For points, search now. We have some problem here. Must be covered by boundary. Why not? This is actually a problem, obviously. I think I validated that. That's why it's not showing us any error. Oh yeah, now go to zoom to. Where is this one? Yeah, this one. So just what can I do for that? Just delete it. Okay, then go to second one and zoom to it. So it's inside our inside our polygon, but why is that showing us as one error? Because it's actually, I think it's our library, that's why. So it's exception, it's also exception. Okay, fine. Now you don't need to actually validate it, because the editings are actually occurring on our real shapes, real feature classes. Okay, so now you can delete it, remove that. Do you want to save edits? Yeah, of course. Now that you have seen that just in this small data set we have huge errors, so in a large data set you really want to try that one, this topological correction. If you are a GIS professional, you definitely use this topological tool. Okay, so if now I just delete it, you can delete it, yes, fine, it's not a problem. Now I can what again, if add those things, shape, you can see all the what errors are gone. We have no errors, no points outside the boundary. Okay, so that's it, that's all about topological rule.
Alright, now in this video you're going to see how to create a base map of your own. Maybe we'll not see how to create this type of base map, but we'll see different types of study area mapping. But if you are facing trouble on making such one, then feel free to comment in the comment section down below. Now we'll see a pre-recorded video. After finishing it, we'll be right back with new ideas. Okay, you have to download the country shapefile. So if you don't know how to download, I am assuming you are a beginner, so head over to devgis.org, then go to free spatial data and then country level. After that, select your country and administrative area. Okay, download a zip file, then move it to a folder and extract it, then back to our ArcGIS. And to add your data, click here and go navigate to the folder where you have stored your data, then okay, add it. Fine. Now let's find out our study area. So go to properties. Oh no, we don't need properties, we need attribute table. Go to open attribute table. Fine. Now you have to search your study area location name from this attribute table, and in which column your location area exists. It's actually difficult if you have a big shapefile, so we're not going to do that. So we're just going to search our study area name. So it's SADR. Fine. Now you can see in this column ADM3EN, your study area located. Your desired study area name is located. Fine. Then now to select that study area, just go to selection, then select by attributes. Fine. Now here you can see all the column names and select the column name where your location lies is equal to, then a quotation mark and write your study area name is. Fine. Apply. Cool. We found it. Then we need to cut that or clip that. Right click here, go to data, export data, then save it in a folder. You can browse here. Okay, fine. Okay. No, I don't need it. So this is our location map. Fine. Alright. Then now click in the down left corner, view. layout view. Fine. We don't want this layout, then go ahead, file and page. I'm gonna give it a 4 and landscape. Okay, fine, just resize it. That's the boring thing. Fine. Now what? Now I want to show this map in my original, that is large mothership file. So to do that, at first go to insert and insert a data frame. Fine. Then go to here, this catalog. Click here. Then navigate to the folder where you have stored your data, shapefile data, country shapefile. So I have really and drag it here. Now you can see your country shapefile is here. Just right click and zoom to there. Right click and zoom to there. Fine. And drag it. Alright, now let's say you want to highlight your study area in the big shapefile, that is your country shapefile. So how do we do that? So to do that, you have to again add your study area map in this second data frame. So now again go to the shapefile, you study area shapefile, and drag it here. Now if you uncheck it, you can see this is your study area. Fine. So at first hollow it, otherwise you can't see your study area. Then change the color. I'm gonna give it red. Alright, cool. Now you can see this is your country shapefile. Sorry, your study area. Okay, now you can draw something like I'm gonna give a line. So double click. Again, it's actually line, this line. And again. That's it. So now if you want to provide grades, it's pretty simple. Grades, new grid, okay, next, levels only, I want it like 9. Next, finish. And apply, you can see the grids here, and these are pretty small, and I don't like this format. There's a horizontal format, I want it vertically. So go to again properties, and here check right, and I don't want to check it for left, sorry, because in the left side I already have another map, so I just want it right. Okay, apply and increase it to 8. Okay, fine. Nice. And because I didn't check the left side, that's why in the left side I don't have any coordinates, but if you want you can give. And if you want more coordinates, just you can change the interval of coordinates, interval of latitude, longitude, degrees. So from here, from this section you can, like, say 5 by 5, then there will be more coordinates. Okay, good. Okay, now you can make some coloring and make it more compelling, like go to the shapefile properties, then Symbology, no, levels, and check this level features, and here expression we are going to select ADM4. In this column we got our union names. Apply. Now you can see names right here, and they are small, so we are going to increase the font size 12 and bold it. Fine. Apply. Okay. Now you can see that it's no more appealing than the previous one. Okay. Now I can color this map by different name of the location. So to do that, go to Symbology and categories. Here unique values. Under unique values, go to value field and again select the same column, then add all values. You can change the color ramp. Okay, apply. Okay, now it's colored. Then what you can do is insert some text here. Oh, it's pretty small. Okay, what do you want, like study area, and change size of the final world. Oh shit. And place it here. Fine, you can add scale, not thorough. Scale bar. Fine, and I don't need the legend because you can see which union name is what clearly from the map, so why legend? But if you want, you can insert it. Just click here, legend, next, and you can provide a background like next, finish. This is your legend. You can group it, you can resize it by just group it, resize it, etc. You can do many things with this, but our focus is not that. We want to create another location map where we can see where is the river, where is built up areas, everything. That is, we want to create another star area with a satellite image, using a satellite image. So remove all of these. Okay, to make a desired image map, you have to at first download satellite image. So if you don't know how to download one, then you can watch my video on how to download cloud-free satellite image. Okay, then extract that satellite image and you have to do one thing called composite file. You have to make composite file. I have already made my composite file. If you don't know how to make this composite image, you can watch my another video on land use classification. It's just a 2-minute task. Fine. Now again input your study area. Where is my study area? There it is. Okay. Next, go ahead to Windows, search, and here write extract by mask. Then hit enter. Okay, under Spatial list tool. Fine. Here use satellite image. Then use study area. Specify a location. Save. Okay. Okay, fine. You can see our extract by mask is ready. So now we don't need the previous big tile. Remove it. Okay, zoom to the layer. Oh, it's quite different. You have to extract it, export this map. Fine. Okay. Now I want to make this one as my study area map 753. The same color combination color you may find in land 7 when it's 742. Use analysis. Okay. Now you can see over here, this is built up areas. This is a river, Ganges River. It's pretty informative. Now how can we make it like our previous one? So, oh shit, it's default. So now what we need is insert data frame. It's like previously how we did previous made our previous map. It's pretty simple that way. So where is our country shape file? There it is. Fine. Make it a little bigger. Then zoom to there. Fine. Now again extract this one or just the shape file you had or have here, and make it hollow. Okay, I change the color red. Okay, now you can see again you can draw a line. Now you can write here the river name like it's Ganges River. So go to insert text. What Ganges G river. So I want to rotate it. So angle 52. Change symbol 10 volt. Okay. Oh, what is that?
minus 52. Okay, fine. Now if you want to add your location data, that is your stations, you can add them, add data, then add XY data, your coordinates, go to the folder where you have stored your coordinates and make sure your coordinate system is in WGS 1984. Go to edit and make it okay. Okay, fine. Now I'm gonna change it. Fine. Now if you want to add legend, you can add it. Insert legend, next, background, next. Okay. Now we don't need this RGB, so to delete it, just convert to graphic. Then again ungroup it. Here you can select which one you want to delete. Delete them. Again group them. Fine. Okay, fine. Now if you want to add legend, you can add it. Before that I'm gonna change it to stations, STAT, or sampling locations. Fine. Now I'm going to insert legend, next. We can give a background, finish it. Okay, convert it to graphic because we don't need RGB. We are gonna delete it. Fine. Delete them. Okay. Now again group them. Group. Okay, fine. That's a legend. So again, if you want to add coordinate grids, you can add them. I'm not going to do that again, so it's now the final part. So we're now gonna just export it. Export map. Okay, JPEG. Just 300 dpi. Okay, save it. Desktop. Save it. Fine. Now you can see it. That's it. This is our map. Okay, fine. That's it for now. I think you've learned something. Previously you have seen how to make a map like this. Now you're going to see how can we add two different maps together. And before we move on to adding two different maps together, let's just see how can we add one Excel file with our existing maps attribute table. So now let's see, say for example, this is district data, district wise district names, or you can say state names, versus number of solar panels installed. So I just want to geographically show or plot this data in a map. So to do that, you need to
join this data with your one existing maybe shapefile. So let's go back to ArcGIS and delete this map at first. Now, yep, fine. Now I'm going to load one country shapefile. So it's actually Geodatabase. Fine. Now what? Let's see the attribute table of this. Here we also got one state name in this map. These are just all the district names of Bangladesh. Okay. Now our task is to drag that CSV file in our ArcGIS, and remember to save that file, Excel file, in CSV format. Okay. Now you can open that, see that district names. Fine, Bhola Bogora, you can see Baghat Bandhavan. Now before you join, you need to confirm that there's one common column name in between in your Excel file and also in your ArcGIS map. If there's no common column, then there's going to be no joining. Okay, so open attribute table and you can see Baghat Bandhavan, same thing, and it will actually match every word, single word. If there's any spelling mistake or any spelling discrepancy in between two of them, then there will be none, or that will not be joined. Okay, so to join, right click here and go to join and relate join. So join attributes, you have two options. We're going to join from a table and choose the column which is common in between both of them. So this is our text column, and here keep all the records. That is, we are going to keep all the data whether they are common or not. So if there's some data not common in between both of them, then we'll see some none values. Fine. So if you are familiar with SQL, then it's actually inner joining, and if you just it's outer joining, and if you just select this one, keep only matching records, it's inner joining. Okay, so we want to see all of them. Fine. So let's again see the attribute table. Now you can see we got all the district names added with our ArcGIS map and corresponding number of installed PP cells. Now if you double click here, then you will see all the NaN values. You can see two NaN values, and maybe because they didn't match, the name spelling didn't match, so you need to again edit this column so that they can match and you will get the value. So for the time being, I'm just going to start editing. Okay, no problem. Just a random one. I started editing, but I can't edit. Oh, I need to export this map. Now the second task is to export this map, because to save all the changes you have just done. So to export it, data, export data, store wherever you want. Okay. What is that saying as we can't create any? Oh, okay. Stop that editing session. Stop editing, and we are now going to export data. Let's export it. Now we don't need them anymore. Now if you see the attribute table, you can see number of installed, district, and NaN values, and you can manually edit them. Let's say this, for this zone it was 1050, and for this one it was, let's say,
500 just. Okay, now save it and stop editing. So that's it. That's how you can join to different attribute table in ArcGIS. And if you are interested in visualize this data, you can do that. Go to properties, then symbology, and categories. Yeah, categories, quantiles. Yep, quantiles. Let's say we are interested in graduated colors. So here click the value, and we are interested in this installed PV cells. Fine, you can classify it on, let's say I am just interested in 4 classes, and it was natural break. You can do equal interval or quantile. Fine, let's see 4 different. Now you can see one nice colored map, and with number of installed PV cells range. So this one is the lowest range, those color. Okay, here it's highest. Okay, now you can also change that symbology. Let's say you want 4 classes, yeah, but you can manually change this class range. Let's say you want to start from 2000, then second one you want to be in 5000, 50,000. Yeah, I think so. So on there, yeah. So you can do that, and you can also change the color. Yep, if you would like to. So that's it. That's how we do such thing. And next we are going to see how can we join 2 different layers attribute table. Okay, now we are going back to our previous data. This GIS MXD. Okay. Yep. Now you can see this is a library layer. This is school, then roads. Okay. So if you go to the library attribute table, you can see some library names. Fine. And here we'll see some school name. So I'd like to join those school names to library names, and we're also interested in the closest school or closest library from a school. Okay, that is, we want to know which library is close to this school, and also we'll see the distance between them. So let's see that how can I do that. Let's say we're going to open the attribute. No need to open attribute table. We're going to join, but now you don't need any common common attribute. Okay, so join from data from another layer based on spatial location. So choose the layer to join. Okay, fine. Now you're going to select this one. Each point will be given all the attributes, and this is going to be a new layer. Okay, fine. Join output 3. Okay, so yeah, it's joined. Okay, now if you see the attribute table, you can see open attribute table, and let's see. Fine, school name, library name you can see, and also the distance. Just close. Yeah, so you can see this X, school name X is, sorry, library name X is closest to school D actually. Yep, and the distance is about 66 kilometer. Fine, it's not kilometer, it's I think meter in, so 66 meter, pretty close. So that's, I would say, a really powerful joining, by which you can also measure the distance between 2 features. Now you can also measure the distance between 2 objects manually. using this tool here. Okay, so let's see which is our D, school name D. Attribute table, school D, this one. This is now here. If you click here, then what? Why is it showing us? Find, go to X. Okay, now here, click here and double click here. You can see 68 meter, and we found that what? Open attribute table. D versus X, 66, 68. I'm pretty close. Maybe I got some error here, but it's fine. Okay, now if you would like to join this attribute table in one of your existing feature layers, let's say you want to join that feature table in this library table or school table, you can also do that, because we have a column common. Let's say school name is common in this join output, also it's common in this school name column. Okay, so right click here, open, go to join. So join data. Now we are going to join table, not layer. Choose the field in this layer based on school name. Choose the table to join. Yep, join output 3. Yes. Then choose, yep, everything else. Keep all records. Keep only matching records. Okay, keep all. Fine. Click. There you can see school name, yeah, here. Why double school name? Why? Library name, distance, everything is here. Fine, so that's enough about joining different layers or attribute tables. Let's now see how can we join two different maps together. So let's say I am just going to add one new shapefile. New feature class. And name it new shape. Okay. Next, and just one column. Name, and its text. By default name, I would like to say, let's say, yes, no problem. By default, let's say it's KZI Kazi. Finish. Okay, so we are now going to edit. Okay, now you can see this new shape. Yep, new shape here. So you're just going to create one new shapefile that has nothing to do with this existing shapefile, but we assume they do share common border. Yep, so we assume that they do share a common border, but you can see there's one gap in between them. But don't worry, when we merge them we can fix that. So let's say I want to merge these two shapes into one. So what we can do, we have two options. Just go to here, Windows, search. Okay, one is union, UNION, union. So union 3D analysis. We're now going to new shape and merge. Okay, output file name union. Okay, So we have connected both of them. Let's just unclick rest of them. So here this U, delete this U. Where is that U here? Okay, now if we go to the attribute table, we should see two polygons. Open attribute table, but here you can see we got three polygons. This one, okay, fine. It's the previous one, okay, but this little one is one actually error. If you double click here, it will zoom. So we need to merge that with this one. So to merge that, you need to select both of them. Just hold shift and click this polygon. Okay, now add it and merge. So you can see this is the valid one. So double click here, this is merged. Now you can see that still there's some problem here. You can also fix that. How? By just double click here. You can see this vertex. So just we are going to, yep, I think it's now right. Okay, so if there's still some problem, you can also merge both of them into just one. That's another line. This line we can remove that. Just delete vertex. Delete vertex. Now it's gone. Again, you can draw a boundary from here to here. Yep. Now there should not be any error. Yep. So that's one kind of joining. There's another joining, that is merge. M-E-R-G-E, merge. And I would prefer this merge tool, but it depends on the attribute table. If you take a look at the attribute table closely, then you'll see the difference between merge and union. And if you have any questions about them, please let me know in the comment section down below. Okay, now let's see how does this merge operation or tool function. So again, just these two, new shape and old shape, new shape and SHP. Fine. MERG, merge. We'll do merge when we have two common features, two common columns, or you can say attribute in the attribute table. So, and we are going to join two large maps having same attributes. Then we use this merge tool. Okay. Let's see. Close that. You can see fine, same thing what we have seen before, but just a little bit of difference in the attribute table. Now you can see only two attribute table, and if this is actually one name with capital letter, starts with capital letter, and this one starts with small letter, but if the spelling of that two column name are same, then you would see just one column named name, not two. But in the case of in the case of union, whether they are same name or not, you will see always two new column names. Okay, that's the difference between merge and union, I would say. Yeah, major difference. And we can see here a bit of what error as we fixed those problems previously. We can also same way you can solve this problem also. Okay, so fine, that's all about merging, joining, and I think I showed all kinds of merging in ArcGIS, possible merging. Maybe there's some other merging or data joining. Yeah, actually some other types of data joining exists. Say join, if you go to there, join. There's another type of joining. You can see here, this one. And sometimes you can join if you don't have any primary key by just geological or spatial relationship. I'm not going to show you that. Okay, cancel that. So that's it for today's lesson. Okay, now in this section we're going to see different types of buffering in ArcGIS, and we're going to start off by just the common one. Okay, so to start buffering, Control F. Yep, you need to just write here buffer. Okay, then go to this buffer analysis, double click here. Okay, now you need to select the layer on which layer you want to perform buffering. So let's say I would like to use this road. Okay, location, saving location, buffer, save that. Let's say I want to create a buffer zone of 30 meters around the roads. Okay, so 30, maybe it's a restricted zone. Okay, so okay, now close. Now you can see that we have made a 30 meter of buffer zone in the both side of the road, and this overlapping appearance isn't looking great, so we can dissolve that. Let's just delete that one, make another one. So again we're going to select our road, then location. Okay, meters, 30 meter, and we want to dissolve the overlapping boundaries. So here under this dissolve type you can specify all. Okay, close that. Now you can see all the overlapping areas are gone. That's fine. So now let's see, say for example I don't want same buffer zone for all the road type. Maybe for highway I want 20 meter buffer zone, and for village road I want 30 meter buffer zone. So how do I do that? To do that you need to modify your attribute table a bit. So let's go to the attribute table of river road, sorry, road. Yep, here you can see the diameter of road. Now if it's a highway, okay, then diameter we said maybe it's for buffer zone 20 meter, and if it's a village road, and then we set it to, you can see here 30 meter. You can edit it by just what you want actually. So let's now see how do we deploy that. So again go to buffer, input the layer, okay, output location, then we don't select this one. Now you're going to select this field. Okay, now you're going to select the field which is going to participate in this buffering. Now diameter, okay, again dissolve all. Let's see how it turns. Okay, oh no, I have selected maybe this road, that's why I just deployed on one road. So remove that. Yeah, unselect that, then again go to buffer, do the same thing again, field and diameter, them all. Okay, fine, close. Now you can see this buffer zone is a bit smaller than this one because it's 20 meter and it's 30 meter. So
By this way, you can make different buffer zone for different, it's a feature class, not feature class actually, symbology, road types. Okay, different attributes. Now let's see another buffer method, that is multiple ring. Let's say you want to make multiple buffer zones for one road, maybe for some different purpose. So let's see how can I do that. Remove that. Again, now we are not going to use this buffer analysis. We're now going to the toolbox. Yep, here you can see this is the buffer one that we have used. Now we are going to use this one, multiple ring buffer. Okay, now double click here, input features, our road, output location. Okay, now distance, let's say I want to create a buffer zone of 10 meter, then 20 meter, and 20 meter, and another one of 30 meter. Okay, okay, default dissolve all. Okay, distance, uh, unit meter. Okay, let's see. Now our buffer is, now you can see we have three different classes, 10, 20, 30. This is 10, this is 20 meter, and this is 30 meter. So that's it. That's all I have got for you about buffer tool in ArcGIS. Up next, we'll see quite interesting one, that is data filtering in ArcGIS. So move to the next one. Greetings folks, in this tutorial we're going to talk about some of the data manipulating, data filtering and pre-processing techniques. And it turns out that some people at the beginning of their journey, they seems overlooked this data pre-processing, but it can significantly save you time and efficiency, working efficiency, I would say. So without further ado, let's get right into the video. What you can see in front of you, it's actually a real world um, GIS problem. It's a national map making project, and here you can see that this is actually boundary or shape some polygons of an area, and these are the roads, different road types: national, regional, zilla road, okay, village road. Now, for the convenience of your understanding and so that my laptop would not freak out, I have deleted huge amounts of those data. It was really a big one. And these are some landmarks. These green dots are some of the landmarks. Okay. And what? And there was also some other layers as well. I have deleted them for the convenience of our understanding. As I said before, and let's just take a look at those layers. Okay, here this is our geodatabase, and if you just take a look, you can see here we had this forest layer, image index layer, then landmark 3D. I have edited it already. Remove that. We also had river network. You can see here. Then road. Yeah, we already have that. Water bodies. Also water bodies. Now if I just zoom, you can see how complex it gets. We are not going to use that. We are just going to delete all of them. River image index, road. Yep. Let's just start our working. Now at the first step, I'm going to show you guys how to select some particular areas of your dataset of this shape. Okay, you can select a polygon by just this tool, select features, this tool, just click it, then click the polygon where you are interested. Now you can see this is selected. Now if I head over to the attribute table, you can see this one is selected, and if you just double click here, it will be zoomed. Okay, this one is just selected. And now to unselect this one, you can just click here. Okay, or you can just click outside of this shape, it will be gone. Okay, unselected. Fine. Now there are some other ways of selecting. Another one is by just starting this editor toolbar, then select this one, click on this one, and click on your desired one. Okay, you can see this one selected. Yeah, here this one selected. And similarly, you can unselect that by just clicking outside. But if you select by this editor toolbar, you can see, if you right click here and attributes, you can see the attributes. Okay, but there's another way of saying all those attributes associated with this with this polygon. So just by using this one, identity. So click here and click on anywhere you want. It will pull out all the data for that for that polygon or whatever it is. So you can also select that the layer for which you want the data. It's for EA boundary, this one, this layer. Okay, okay, I got it. I can see that. Yeah, now you can see all the data associated with this one. Sorry, this one. Now you can see. Okay, fine. So these has two ways of inspecting or selecting your shapes or polygon. Now we are going to see another one, that is SQL command or SQL command using. If you are familiar with SQL, then that's fine. But if you don't know about SQL, that's also fine, because SQL is just normal plain English language like. Okay. So to select, you will go to the select toolbar. Select by attributes. By attributes mean we are going to select by some of the columns present in our attributes table, like moja name. Here you can see union, word, etc. Yeah, UID. Okay, so yeah, now select by attributes. So let's say I want to select some of these some of these polygons. By the way, that's another thing to show you. Let's say I want to select more than one. You can select by just this way. You can see more than one. And if you can also want export that map, this selected one. If you just go to right click here and export that data, export data, you can export that as a geodatabase or as a shapefile also. Okay, you can here specify that shapefile or personal geodatabase. Okay, so let's say I'm going to save it as a geodatabase. Save. Okay, okay, let's now, how is it here, zoom to the layer. You can see this is now exported. You can now also see that in Google. What you can also open that in Google Earth Pro. Okay, so let's just delete this one. Okay, so we are in the selection, select by attributes. Okay, let's say I wanna select some moja name. Okay, you can also select from this attribute table. Here you can see here more than one also if you would like to. Okay, unselected and clear selection. There's another way of selecting. Let's say you just want to select everything, every polygon except this selected. This, let's say 10 polygons. So to do that, just switch selection. Now you can see all the polygons are selected except those selected at the first moment what you selected. Okay, really cool one. Okay, fine. Oh, I forgot some other ways of selection. If you just go to this selection, no, here, not here, this one, you can see select by polygon. Let's just open this one. So let's say now you can create a polygon, and inside that everything inside that polygon will be selected. Now you can see everything inside that polygon is selected. Okay, yep. So now there's another way of selection, that is select by lasso. This lasso is just you can make irregular shapes, whatever you want, they will be selected. And is there anything else? Circle, create a circle and everything inside that circle will be selected. Okay, there's also one another thing is called select by graphics. Okay, so I think I'm not going to show that right now. That's enough about different selection types. So now let's see select by attributes. Well, now you can change the layer on which you are going to perform that SQL query. So let's say I am interested in a boundary, and right here you can see that modular name. I am interested in this modular name. So in a big data set, maybe your modular name is not here, it's um, in a distant place, you can't find that easily. Just close that for a moment. So in the case of that problem, you can go to the properties, then this field. Okay, then you can, this is what modular name here, move that to top, so you can easily find that field, and you can unselect some unnecessary fields. They are not going to be deleted, they are just temporarily not going to participate in your geodatabase. Okay, so I can do that. Okay, so apply. Now you can see this modular name, this column is now at the first place. Now you can easily find that column. Okay, then again select by attributes. So I'm interested in this modular name. So here this is, they already have written some SQL query for you, so that it's going to be more easy to you. Select every column from, this star means everything from EA boundary, this EA boundary column, this EA boundary layer, where modular name equal, you don't have to use double equal, just one equal is okay. Let's say get unique values. You can directly write a name, just copy it, Ctrl C, then you need to paste it, but before pasting here you need to paste it in between quotation mark. So apply, you can see that's selected here, this one selected. But there's another way of selecting. Okay, it's by this get unique values. Now you can see all the names are here. You can select anyone you want. Let's say if you write here, first one was MAL, you can see here, apply, and it will do that quotation mark for you automatically. Okay, now we just selected one single polygon. Let's say you want to select multiple of them. Alright, now I'm gonna select another polygon, let's say this name, but if you just write this way, you can verify that it's an error. It's not a valid SQL command. Okay, you cannot use that way. So you need to use one operator. This equal is an operator, and now we are going to use another operator, and we're going to use either and or this or operator. Now if you're going to select something in the same column, you can say that you can't use that AND operator, because in this same column there's no field where there is you are going to match two names at a time. In this field there's not two names, it's just one single name, so you can't use AND. You need to use OR operator. So it's going to find the first name, then second name also. Okay, so let's just uh, name, let's see this one. Or again you need to use name equal, let's say this one. So it's just two of them. At the middle, just the name. So we want this one or this one, and if we have both of them, then it will return select both of them. If we don't have one of them, then it will at least return this one. Okay, so if I just verify it, you can say it's successfully verified. Now I apply that. Okay, you can see two of them are selected. Okay, apply that too. Now let's say you want to select another polygon or another name. So again you need to repeat that. Again you need to write that or, and then name equals dot 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 dot. But there's another way of doing that. It's actually easiest one. So we're not going to use this or equal operator. Now you're going to use this in name in, then you're going to use this parenthesis or bracket, and within this bracket we are going to pass our desired names. That's this one, then use one comma, this one, also this one, there's three of them. Okay, now you don't need to use any and or. Okay, fine, just apply it. Oh no, what's the problem? Okay, name in, oh I forgot to put a comma here. Fine, apply. Now you can see all of them are selected, this one, this one, and this one. Okay, now clear that, clear from here. Now let's say we want to select a range of names. You can't select range of names in SQL, but in ArcGIS, as our names are sorted, you can select range of names using between operator. So I need to write that between. You can write that in small letter, that doesn't matter. Okay, so merge name between, let's say this one, and you don't need to use any and thing here, between comma. Okay, let's say verify that. No, it's not verified, you need to use one and, I guess. Yeah, now apply that. Yeah, it should got selected. Yeah, successfully selected. You can see now all of them are selected, this range of names, but the range of values you can select by between operator because it just works on integers. Yeah, but it doesn't work on string, but in this case it works in ArcGIS. Now let's see the valid use of this between operator. Let's shape area, unique values. You can see shape areas, some of them. So let's say I want shape all the shapes where area is in between the T in the middle in between this one 19 kilometer and let's say this one, so in between this range. Apply that. Okay, now it only selected those polygons where our query criteria met. Okay, fine. So let's again select by attributes, clear that query, and what we can also use some other operators. Let's say what is that, shape area greater than this one. Apply. Okay, it will save all the polygons where shape area is greater than that value. And that seems like everything is such selection. Ah, only this, I think, 4 polygons didn't match that criteria.
Now there's another way of doing such things. Basically, when you want to narrow down your dataset, or obviously it's going to be more faster. Okay, let's see how to do that. So just double click here. That is going to property. Yeah, then go to this definition query. We are going to build a query. Okay, and this time we are going to use 2 different fields. Let's emoji name equal what this a h, this one, and you're using another field, and here you would say union or word name equal, let's say b m, this one. Okay, you can also see right here this, I can select it, the matched this one, yeah, verify that. Yeah, okay, apply. Fine. Now let's just zoom to layer. Now you can see only this polygon is selected right now. Everything else is just vanished, but they are not deleted. I haven't created any new data set. If you just go to properties again and clear that query, okay, you will see the previous data set again. So it's not going to actually delete your dataset. It's just going to narrow down your dataset for you to be more what? To be more efficient, or you can do your task more easily. Okay, zoom to layer. Fine. Now if you take a look at this attribute table, you can see now all the fields are available only for this polygon. Okay, fine. So we often use this definition queries so that we can do our task more easily. Yeah, so let's now see why we use such definition queries, or we select something. Yeah, so just remove the definition query, clear, okay, apply. Okay, so it's back to the normal condition. Now let's say I'm going to landmark field, open attribute table. You can see this is landmark name. These are some names. You can see crop field, paddy field, post office. Okay, let's zoom it a bit. Here you can see that this is land name. We also have some landmark code. These are specific for certain type of landmark name. So let's say I want to do something like when landmark code is 47,
I want to say that LM type is fields, any type of field. And when landmark code is 44, I want to say that it's a mosque or temple, such things. So I'm now going to create a new field, and you can say we are going to use a reclassification. So based on these landmark codes, how can I do that? One way is, let's just sort it. Yeah, let's say for 9, these 9s, the LM type is, it's a text field. So let's say if code is 9, then LM type is none or some office field calculator. So you can see VB script or Python doesn't matter. LM type equal, say for example, what, office. So you need to write that in quotation mark. Fine, and close that quotation. Okay, that's taking that long time. Yeah, you can see office only for those two fields. But it's not a good choice when you have got a large dataset. We can do this for this small dataset. We can do that manually. You can see for 47, you can again go to this LM type field calculator. We can write anything you want. Okay, say okay. That was a failure. What is that? I don't know. Field calculator. Okay, is that double quotation sensitive? I don't know. Python isn't sensitive to that. VB script. Yeah, if you are using VB script, then you need to use that double quotation. But if you just convert it to Python, then you won't need to do that. Let's see that. Just one quotation. Yeah, it's worked. So if this is a small data set, then it's quite easy for you. But this data set was around, we got 22,000 rows. And in that case, it's not actually feasible for you to every time do that manually. So you can, now you can use that selection, select by attributes. Why was it? Landmark field, yeah. So you are where landmark code. Okay. Landmark code equal get unique values 44. Apply that. Okay. Now you can see all the landmarks code where the code is 44 are selected. Now you can go to LM type and use your field calculator, and let's say it's a mosque or what, or temple. Okay. Okay, so now if this is a huge data set, it doesn't matter, they are all selected. You can see, yeah, mosque or temple. So then again you need to manually, for another class you need to again select that. If you can also match two fields at a time. Okay, you can also see a landmark name equal this one, and let's say LM name equal something else, so that should match both of them. Then you will get one what, new type. Let's say this one. If the LM code is no, it's not going to work. Now it will work. If 15 and LM name is this one, apply that. it should get selected. Yeah, that's one. You can see this one, this landmark. Now you can again apply that field calculator. Okay, so but this is not actually very fast, or you can say you need to again and again do the same thing. But there's another way if you are familiar with Python. But if you don't have Python background, it's okay, because writing such else elif statements are not that hard. Let's now see how Python can do the whole thing by just at once. Okay, so yeah, let's see a bit of code. So this is our code, just a simple function. This is defining a function or a custom function. This is a name. You can give any name you want. Now this function takes some parameters, and this is a parameter. You can give any parameter name, x, y, z, etc, etc. So now you're telling them if x equal 15. That means our code, landmark code, if x equal 15, we are going to return house. And elif, if otherwise, if x equal 44, then we will return mosque or temple. And by the same way, elif we can make it long, but we are not going to make it long, just we're going to else if the condition doesn't meet this 44 or the code is not 15, then we are just going to return others. Okay, so just copy this function, copy, go to your ArcGIS interface. Now before that I am just going to unselect everything, and this LM code field calculator, make sure that you have selected this one, parser Python. Okay, then just delete this one and click this show code block. Okay, now paste your code here. You can see our function here. Now just you need to write that function name here, fun, then in parentheses we are going to pass the field name, that lm code. So the x is replaced by this landmark code. Okay, now let's hit OK. Oh no, everything is like, oh yeah, fine. Yep, now you can see when it's not 44 or not 15, it just returns others. If it's 44, then mosque or temple. Otherwise, if it's 15, then house. And we can also what, let's say if it's not 44, not 15, then we are just going to return our x. That is just the code. We want just the code. Fine, let's again copy that. Let's again see field calculator, and yeah, okay, fine. Now you can see just the code 2626, but if it's 15, then it's going to write house, or if it's 44, then it will be, yeah, mosque or temple. So that's really on fast thing. So I would say, yeah, you'd definitely prefer this Python syntax other than those what SQL or manually selecting things. So now if you are familiar with Python, now you might be wondering why this 15 is in this quotation mark, because this 15 is actually integer. So integer doesn't take that quotation. Quotation takes when this is a string or it's a text. Now I am treating this 15 as a string. It's because in this lm code field, if you go to properties, you'll see that its type is string. We stored these values, these codes, as a string. That's why you need to use that quotation in our Python syntax, this quotation. Okay, if it was a what, this type was an integer, then you don't need to use that quotation. Okay, now finally let's talk about select by location. And this is actually one power of using spatial analysis. Let's see how to use that. Selection, go to select by location. Okay, let's just delete them. Okay, now let's say I want to know, or I want to find out all the landmarks which are within the 100 meters of our road network. Okay, so to do that, again go to select by location, then select features from this one, landmark field, on which field you want the output. So select that field. This is our landmark, so we want all landmarks that are within 100 meters of the road network. So here you need to use road network. Okay, now we are going to use the, we have bunch of conditions. Let's say are within a distance of the source layer feature. Okay, so here by default it's 15. Let's say you want to know, yeah, let's say 15. You can also change the unit. Okay, apply. Okay, now you can see all the landmarks which have or which are within the 100 meters of a road network got selected. Now if we go to this attribute table, you can see they are selected. You can see here only the selected ones. Fine. So if we just switch selection, or you can see out of 350, 240 got selected. So there's 110 landmarks. Those don't have road network within 100 meter or 50 meter. Okay, so that's how you can use that select by location. Okay, so I'd say experiment with it a bit more. You'll find out some interesting things. That's it for this video. Hey guys, so welcome again. Previously we talked a lot about vector data analysis. Now in this video we're going to take a look at raster data analysis. And by this time I think you might know that, you might have a bit of understanding of what raster data is. In raster data, it doesn't store data as points, lines or polygons. In this case, data is being stored as grids or cells. Now, if I just zoom over there, you can see now single cell sizes, many. So, and each of those cells are equal in size, and it's 30 by 30 because it's a Landsat 8 image, so its resolution is 30 meter, and the lower the cell size, the higher the resolution. Now you might be wondering how to download this data. To download this data, head over to this USGS website, and from here you can download Landsat 8, 7, etc. images. And I have uploaded a full video around 4 minutes in YouTube. You can watch that to see the process how to download that. Okay, now let's back to our ArcGIS. Okay, now let's see how to do one indexing that is known as NDVI, normalized difference vegetation index. There's a couple of ways to do that in ArcGIS. We're gonna use this image analysis tool. It's I think the simplest one. At first you need to activate that layer, then we need to see our bands. You can see red band is 4, infrared band is 5. You can change them also, but in NDVI our equation is 4 minus 5 divided by 4 plus 5. That is red minus infrared divided by red plus infrared. But if you were using Landsat 7 image, then it would be 3 and 4. Okay, you can do other indexing here also, that is a built-up area index. Then you just need to change them. As long as you need just 2 bands and there's nothing but just plus minus, then you can use this tool. Otherwise you need to use raster calculator. Yeah, so at first activate that, then click on this leaf tool. Okay, NDVI, it will automatically create indexing for you. Alright, now you can see a new layer where values are ranging from -1 to 1, where highest value indicates high vegetation. Okay, now before we classify it, let's say for example you're not interested in this whole tile. Okay, you're interested in a specific region. Now let's say you're interested in this region. Now you can cut that. There's many ways to cut it. One is by this graphic. So let's see how to do that. At first we are going to draw a polygon here. Let's say you are interested in this area. Okay. Now to cut this area you need to go to this layer, right click here, go to properties. Okay, then what? Then data frame. Now clip options, no clipping, turn it to clip to shape. Okay, now specify shape, current visible extent, outline of selected graphic, I guess. Yeah, outline of selected graphic. Okay, and then apply. Now just delete this shape. You can see that zoom to layer. Oh no, the band is only showed, or is only you can see for that graphic, your expected zone. You can also undo that. Just go to properties again and clip, no clipping, apply. Okay, it's our previous thing. Now there are some other ways of clipping or masking. Let Control F. You can use here CLIP, clip data management. If you are clipping any vector data, then you need to use clip analysis, I guess. But in case of raster data, you need to use this clip data management. Okay, here you can input your raster. Okay, NDVI, but we don't have any shape yet. So let's say what? Let's say this is your study area. You want to cut that Landsat image for only this study zone. So to do that, you can use that clip, or you can do masking, and we preferred to do masking, extract by mask, not clipping, because I found that masking seems to give you better result than clipping sometimes. So extract by mask, spatial analyst. Okay, it's pretty simple. Input raster, our, let's say for example NDVI 8 composite, then input raster or feature mask. What to mask? It's our shape file, and this is output shape. Location, save that. Maybe it's too big. Okay, now it will cut that Landsat image only for that shape or only for that zone. Yep, successfully done. Now here you can see, zoom to layer. Yep, only for this study zone. Okay, remove that. Alright, now we are going to classify it. Go to properties, then Symbology, classify. Yes, it's gonna take some time. You can see over here it's processing. Okay, I'm gonna do two classes, and there's a threshold that I guess above 2.25, they're all vegetation. and below 0.25 there's no vegetation. It could be water, it could be built up area, anything, but not vegetation below 0.25. Okay, so let's change the color, red to green. Yep. So high value indicates it's healthy vegetation. Okay, now seems like that is majority of the area is vegetated. Okay, but what's the problem in this red one or these red zones? Now you saw that previously that these are, well, just I'm going to 753. Okay. Now you can see these are actually water bodies, and water bodies do have low NDVI value. That's why it's in red. Okay, so this is not vegetation. But let's say, what is this? It's actually built up area. If you just change that to 543, you can see clearly that these are built up areas. And now if we see the NDVI value for that zone, you can see these are red, that is it's not vegetation. Now why this is green, this zone? Now if we just, you can see this is actually green. Yeah, this is vegetation. This red color means it's vegetation. Okay, now if it's dull to you, you can again select it and activate that DRA. Now it will be a bit bright. You can see it's now bright. You can also activate that swipe tool. Why is that swipe tool here? Now you can swipe it. Yep, sweep it. You can see here that all these are what? These are built up areas, or not, at least not vegetation. So that's a good the good tool to our index to identify which is vegetated or not vegetated. Okay. Now let's see another type of raster data analysis. Let's say you want to plot or interpolate manganese concentration over a country. How do you do that? So you can do by what's called IDW or Kringing interpolation techniques. So let's see that at first our data. These are latitude and longitudes, and we also have our manganese concentration. Now I want to plot that on a map. So at first I need one country shapefile, a geodatabase. So this is my country data. Now I want to import that Excel file in ArcGIS. So before you do that, you need to save it in a different format. Okay, and you can see I have saved it as 97 2003 workbook. Okay, or I think, yeah, CSV file also work, I think. Yeah.
All right, now what let's load that Excel file in this GIS interface. Okay, now go to display XY data. X is our longitude, Y is latitude, and make sure both of them are at the same geographic coordinate system. Okay, okay, fine. So now this is our RDW part. Control F, just write RDW, and if I go to the path, toolbox path, you can see we have another option, Kringing. This Kringing sometimes is more suitable than IDW in certain cases actually. Right now I'm gonna use this IDW. Okay, input raster. This is our input point features. This is our Excel sheet with XY, latitude and longitude. Then Z field is the field which I would like to interpolate manganese.
and output raster. Leave that default, or you can. Now number of points is here 12. By obviously I don't have 12 points. I think I got thousands of points. It doesn't matter. Go to environment, then processing extent. Here we are going to same as our shapefile, and then raster analysis. It's also our shapefile. Okay. Now wait a moment. It's not going to calculate this IDW for us. Fine, it's done. Now let's unclick them for a moment. You can see I can change the symbology. Go to symbology, classify. Let's say I want 3 classes. You can manually change the interval. You could do equal interval quantile or just do manual. Okay. So let's 0.2, then 0.4, then greater than 0.4. Okay. Okay. Apply. Okay. I forgot to change the color. Let's say red to green. Apply. Okay. Now we can see that these red zones are greater than concentration 0.4. Okay. Now you can say that this red zone ranges from 0.4 to what here 8.4. So you don't know the exact concentration at this point. Let's say for example. So to know that, go to properties again, and then display and check this show map tips. Apply. Okay. Now you can see the exact value for a particular point. Now here its concentration is 0.69. Okay. So let's now do another thing. I want to know the manganese average manganese concentration for this polygon, this one, and all of them. Now to do that, you need to know the attribute table, which column represents all of those separate polygons. Then go to attribute table. Now if we is that this name 3, this one actually belongs all those, represents all those polygons. We just click on zoom, you can see this one. Yeah, it's more than one, but fine. We don't have any smaller resolution. So this is name 3 column. Okay. So just unselect it, and again Ctrl F. We are going to use zonal statistics. So you can here zonal statistics under spatial analyst toolbox. So input raster. This is going to be raster feature zone. Our feature zone is BGD. That is our shapefile. Zone field. This is important, and this is going to be that name 3 field here. Input value raster. What's this? Oh, raster. This raster, IDW raster. Okay. Output location. Save that, and now statistics type. You can find out the minimum, maximum, range, standard deviation, whatever you want. We'll go for mean. Okay. Okay. Now it's working. Right here you can see that. Yep, successfully done. Let's uncheck all of them. Now you can see all the values. Now it's spectacular to us that it calculated mean values of manganese concentration for every polygon. Now if you go to categorize it and go to symbology, then
classified classes, again 3. No, classes not 3. Classes, let's say 6. And it's not natural, it's a quantile. Okay, apply and change the color. Okay.
Alright guys, now we are at the end of our video, and I would say probably this is the most interesting and a bit advanced one. And in this section we'll do one overlay indexing method. We'll see that we have different layers, at least we have here 7 different layers, and we'll give different weights depending upon their importance to our study, different weights and different ratings depending upon different classes. Then we'll superimpose one upon another and derive one final index. So it's actually a bit advanced, but I'll say you'll definitely learn something new. Now let's see by one model. So this is our raw data. These are 7 different layers. Then we'll apply interpolation technique on them, then reclassify them. And when we'll reclassify them, we'll give different ratings to them. And after that, in this conventional drastic algorithm, we'll give different weights to different layers and then pull out the final index. Now let's see that into action. Okay, this is my actual shapefile on which I will be working on. What you need is Excel file. It will be required for you. Like in my Excel file, it is well depth, and you can find such information from geological survey in your locality or from literature, some reports, etc. Okay, I am now going to display it in a map, in my map. Now go to File, Add Data, Add XY Data. Okay, you must have latitude and longitude. And X field is longitude, Y field is latitude. Okay, and make sure you are in WGS 1984 coordinate system. If you are not in it, then go to edit section and under geographic coordinate system, go to world and find out WGS. Okay, click OK. Okay, fine. Now we have our data points where we have stored our depth to water table. Fine, now we are going to interpolate it. So to do that, go to Windows, search, and right here you can do it by IDW method or ringing. I am going to prefer IDW. So okay, so under the Spatial Analyst tool, click here. Fine, input feature, it's your Excel file. Z, this is really important. And the Z field, you are going to specify which parameter you are going to interpolate. So we are going to use well depth. Fine, give it a location name, save it. Here number of points, I have 64 points. You can change it, but if you don't change it, it doesn't matter. It will not affect your result. Now processing extent, here is your study area. Okay, now raster analysis, under masking tool select your study area. Okay, fine. Okay, we're ready to go. Okay, successfully done. This is our interpolated map for well depth. Now we're going to these are classes. We're going to sort our classes. Under Symbology section, go to classes. How many classes you want? So to do that, go to a table for depth to water table in meter. There are different classes, 14 meter to 15 to. Okay, depending upon this table, we are going to classify our map. So here there is only one value below 14 meter and highest 28. Okay, fine. So how many classes are there? 1 2 3 4 5 4. Yes. Okay, let me select 4, classify. Now you're going to manually classify it. Here select manual, then it's what is this? It's going to be what the hell? Oh, okay, the lower bound is 13. Now you're going to write here the upper bound, upper limit. Okay, the lower limit is 13.71. Now you're going to write here the upper limit, and our upper limit is 15.2. So right here 15.2, and then it was 22.9, 30.5, 22.9, 30.5, and greater than 30.5. Okay, apply. Fine, you can change the color. Go to Symbology and apply it. Okay, but we don't want to see these values. We want to convert them like this format, 14 to 52. Okay, now we are going to edit it right here. So it was 13 to 15.2. It was 15.2 to 22.9, and it's 22.9 to 30.5, and it's actually greater than 30. Okay, apply it. Okay, good. Now you can export this map, but before that you have to click here. And for me it's actually in default, I have set it like this, but in the case of you it will not be like this. So okay, delete it. Then you can do like make that legend and drag a scale and arrow, north arrow. After that export it, like go to file and then export map, click here and give it a name as you wish. Then here change the DPI. Maybe for paper it's 600, maybe good. You can see the paper paper requirement. Okay, fine. Now our depth to water table parameter is done. Now what we are going to do is we are going to calculate like aquifer media. How can you interpolate aquifer media? For example, I have aquifer media like this, fine sand, silt. I can't interpolate them, but one way you can interpolate them is like if you assign different aquifer media different integer values, like silt is 4, fine sand is 5, etc, etc, then you can again interpolate them. But this way will make some error. It's not actually a good way to do, I think. But when you don't have any option, then you have to do it by this way. Now if you have boundaries like this, then you can do it but without interpolation method. But how? Let's go to our attribute table of Shapefile. See, here we have different union names, and I have aquifer data by unions, so it's a good opportunity for me. Now we are going to make one new column. For what? For aquifer media, because I know that this union aquifer media is fine sand, and this union is fine, it's also fine sand, it's medium sand. So I'm not going to interpolate them, but I'm going to use another way. So let's see how we can do that. So at first you have to make one field here, right here, add field, click here, give it name like you want soil, then type its text. Okay, you'll see. A table is ready for you named soil. See, now you can write here, but normally it will not let you write. So to write here, what you have to do is, what's happening is go to editor. If you can't find it, then right click here. After that, here select this editor. Okay, go to editor and start editing, then select your study area. Okay, fine. Now again go to the attribute table. Now you can write in your soil column. So for example, this union or location, these Aliabad locations, soil is sandy. Okay, sandy, yeah. Now similarly you can assign other soil classes for other locations or unions. I'm not going to do that because I have already done this for aquifer media in this column to save our time. Okay, fine. So far so good. Now we are going to properties, and after properties go to symbology, categories, then here change it to aquifer, add all values, apply. Okay, now see, this is our aquifer media map. Now you can't use it for rating or weighting because it's a vector. So we need to convert it to raster. So to do that, okay, I'm going to my toolbox. So how can I go to my toolbox? Click here, catalog, then it will be like this, then system toolbox. Okay, after that conversion, click conversion toolbox. Okay, we are going to use to raster. Okay, where to raster? We are going to use feature to raster. Double click here, then input feature, our feature. Okay, now select feature field. It's very important, aquifer. If you want to classify soil media, then select soil. Okay, fine. Then fine. There it is. Close. We don't need it. Oh, fine. Now we have two layers so far. Now another thing, important issue is topography. So to download topography, you have to head over to Earth Explorer, create an account here, then here search, go to word feature, here write your location name like DHK Dhaka. Okay, hit enter or show. Fine. Now here you have to specify your time, then datasets, go to digital elevation. After that, here is CRTM. You will see like this. At first clear digital elevation, then select SRTM and check this SRTM 1 arc second global. Then click write result, and you will have one result. Say, then download it in your local computer or machine. Okay, I have already downloaded it. Okay, fine. Now we are going to add this slope map in our ArcGIS. So this is our slope map. This is a whole tile. It's a large area, but we want it for only our study area. Oh shit. Again, study area. Okay, now what you need to do is called mask. To mask it, go to Windows again, search, write, extract by mask. Fine. Under Spatial list tool, write, then your boundary. MMS. Save. Okay. So done. Let's see. Yeah. Shit. There it is. Fine, cool. So now delete it. Okay, good. We don't need it anymore. Right. Now what you're going to do again, this you have to convert this map into slope map. To do that, write slope. Okay, now under Spatial Analyst tool, double click here, then again go to here, input your slope map, then give it a name. Okay, Z factor. Oh, now output measurement. Here there are two things: degree and percentage. Degree is for 90-degree, we consider it as a cliff, but in drastic modeling we use percentage. Okay, I'm gonna leave this Z alone. Okay, fine, cool. There. Oh, no, it's okay. Fine. We don't need it. Okay. Now we need to classify it, but we are not going to do that now. Now our final step is actually reclassifying all of our input data parameters. So we need a total of 7 parameters, but I'm not going to do that for all parameters to save our time. I believe if you can do these 3 parameters, develop these 3 parameters, you will be able to build this model. So without further delay, let's reclassify each of them to give our rating. Search reclassify under Spatial list. Now one by one, at first I'm going to give the slope map. Okay, value. Here you have to put the rating, but we don't need these classes. For slope, let's see something about slope. Range 0 to 2, rating 10, 1, 2, 3, 5. So we need 5 classes. I can classify 5, and what are there? 0, 2, 2, 6, 12, 18. 2, 2, 6, 12, 18, and more than 18. Fine. Okay. Okay. Now new values. These are our ratings. So let's see the table. For 0 to 2, the rating is 10. So our ratings are 10, 9, 5, 3, 1. 10, 9, 5, 3, 1. Okay. 10, 9, 5, 3, and 1. Okay. Now give it a name. It's our slope map, SLOP. Slope map. Save it. And okay. We're done. We don't need this other slope map anymore, so remove it. Okay, now we are going to reclassify our aquifer media. Okay, aquifer media. So in aquifer media, first one is fine sand and silt. First one. So our first one, fine sand and silt. It's 4. So 4, 5, 6, 7. 4, 5, 6, 7. 4, 5, 6, 7. Okay, nice. Now let's change the name to Q aquifer. Okay, fine. Let's save it. Okay, cool. So delete it. Now it's for again we classify well depth for. Okay. Now again classify, you have to, what was it? So at first, if you at the first moment if you classify it, then it's actually waste your time. You have to again reclassify it. So then 1 2 3 4 4 classes. 4 classes. It's actually manual, yes. So what was it? 15.2, 22.9, 30.5, and greater than 30. Okay. Now rating. So depth to a table 5, 3, 2, 1. It's 5, 3, 2, and 1. Okay, good. Now its depth. You have to do this thing for 7 parameters, but I'm not going to do it for 7 all of them, because if you can do for these 3, you can do for all of them. And you can also add, people also add one additional parameter. This is land use class. And if in your groundwater nitrate concentration is high, then land use pattern might be useful. But if the groundwater is reducing zone, actually very highly reducing, then you might not get high nitrate concentration. In that case, people, maybe you don't use land use class. Okay, now we got our 3 classes. You can say 7 classes, for example, hypothetically. Then what we are going to do? Now that brings us to the final stage. And now we are going to rate it. We are done rating. Now we are going to give it weight and have our final index. Then Windows, again search, write weighted sum. You don't have to use that freaking raster calculator. The weighted sum. Okay, 1 by 1 input your all parameters. Fine. Value, you don't have to worry about value. Values are here. Ratings, we already did it. Now weight. For depth, weight is 5. Aquifer, weight is what? 4. No. Aquifer, it's 3. Okay. 3. Now for slope it's 1. Save it. Final index. Okay, let's see how it turns out. Oh, what's the problem? Let's see again. Okay, 5. 5, 3, 1. And give it name final index. Okay, save it. There you go. This is our final index. Now you don't need them anymore, but you can save them. How to save them? To save them, you can go to File, Save, or Save As. Then where you want to save, you can save them, and when you need them, you can directly open this map. Okay, now see, this is our final index. We don't want so many classes. Now let's see, 3 and equal, not equal, quantile. Okay, apply. We're going to use applied. See, this is our final index. Now you can use validation method, like in which area how much arsenic or chromium or nitrate concentration is. So this is your final map. After that you have to insert legend like this. Next, background if you want, next, and finish. That's it. Zoom to layer. Okay. Okay. So now our final map is ready. Well, that's all I have designed to share with you guys in this full course. Now, if you have any questions or suggestions, please comment in the comment section, and I would love to hear from you. So, hope to see you in the next video. Thank you for watching.